All right, let's talk about one of the biggest ideas in programming, abstraction in Java. Now I know, it sounds super academic, right? But I promise you, by the end of this, you're going to see it as your secret weapon for cutting through complexity and writing cleaner code. So, let's jump right in.
You know the feeling, right? We've all been there. You open up a new project, you're looking at the code, and it's just this giant tangled knot. There are files and classes everywhere, and you just have no idea where to even begin. Well, that feeling of being overwhelmed, that is the exact problem that abstraction was invented to solve.
So here's our game plan. First, we're going to really dig into what this complexity problem is all about. Then, we'll introduce the big idea, the principle of abstraction, as our solution. After that, we get our hands dirty with the two main tools Java gives us for this, abstract classes and interfaces. We'll figure out which one to use and when, and finally, we'll wrap it all up by seeing why getting this stuff right is an absolute game changer for you as a developer.
Okay, let's start at the beginning. Why do we even need ideas like abstraction in the first place? Well, it all boils down to one single, massive challenge: managing complexity.
Just think about any app you use every day, your bank's app, your favorite social media site, any video game. Underneath that simple, clean interface, there are literally millions of lines of code doing everything from talking to databases to handling your finger taps. Trying to hold all of those little details in your brain at the same time, it's completely impossible, and honestly, it's the biggest hurdle we face in building software.
So, how do we fight back against that tangled web? How do we make sense of it all? We use a beautifully simple, elegant principle: abstraction. This is our strategy for taming that complexity.
And this is the core idea right here. It's all about changing your focus. Forget about the nitty-gritty details for a second. Instead of worrying about how something works, we just focus on what it does. What's its job? What's its purpose? We treat it like a black box. We know what goes in and what comes out. And for now, that's all that matters.
And here's the more official, textbooky definition. Abstraction is simply the practice of hiding all the messy, complicated stuff, the implementation details, and only showing the essential features to the outside world. It's all about creating a simple, clean interface for a complex system.
You know, it turns out we use this kind of abstraction every single day without even thinking about it. Take driving a car. You interact with a very simple interface, right? You've got a steering wheel, a couple pedals, a gear stick. You know what they do: turn, go, stop. But do you need to understand the complex mechanics of the internal combustion engine, or the transmission logic, or the fuel injection system? Of course not. All that incredible complexity is hidden away. It's abstracted from you, the user. And that's exactly what we're aiming for in our code.
Okay, so much for theory. How do we actually do this in Java? Well, our first tool in the toolbox is the abstract class. The best way to think about this is like a partial blueprint for other classes. It's a starting point. So here are the ground rules. First, you can't create an object directly from an abstract class. It's an incomplete blueprint after all. Second, and this is super important, it can have a mix of methods. Some are fully coded out, which we call concrete methods, but others are just method names with no code, known as abstract methods. They're basically a to-do list for any class that uses this blueprint. They can also have their own variables and constructors. And finally, a regular class can only inherit from or extend one abstract class.
So what does this look like in practice? Well, you might create an abstract class called vehicle. You could put some shared logic in there, but then you'd add an abstract method like start engine. What you're saying is, hey, every single vehicle must have a way to start its engine, but I'm not going to say how yet. Then, when you create your car class and you tell it to extend vehicle, Java's compiler will literally force you to write the specific engine starting code for the car.
Now, a partial blueprint is great, but sometimes we need something much, much stricter. And that brings us to our second tool, the interface. If an abstract class is a blueprint, think of an interface as a legally binding contract. It offers zero implementation. It only defines a set of rules that a class must follow, period. Interfaces are pure, 100% abstraction. There's no concrete code, just a list of required methods. They can't have things like constructors or regular instance variables. But here's what makes them so powerful and flexible. A single class can agree to follow the rules of or implement many different interfaces at the very same time.
So let's say you create an interface called drivable. The contract is simple. It just says that anything claiming to be drivable has to have a drive method and a stop method. When your car class implements this interface, it's making a promise. It's signing the contract, promising the rest of your program that it absolutely knows how to perform those two actions.
And Java will actually give you a compiler error until you fulfill that promise by writing the code for both methods.
So this, of course, leads to the classic question that every Java developer asks at some point, okay, which one do I use? When do I pick an abstract class, and when do I pick an interface? They seem kind of similar, but their real purpose is actually very different.
Here it is. This is the crucial distinction. You use an abstract class when you have an is-a relationship. A car is a vehicle. A motorcycle is a vehicle. They share a fundamental identity. On the other hand, you use an interface to define a capability that completely unrelated things might share. Think about it. A car, a robot, and maybe a remote-controlled lawnmower have nothing in common, but they could all be drivable. It's all about shared identity versus shared behavior.
And this table really breaks down the technical nitty-gritty. You can see right away from multiple inheritance, interfaces are the clear winner. A class can implement as many as it wants. Abstract classes, you only get one. Abstract classes can have constructors to help set up some initial state. Interfaces can't. And look at the access modifiers. Abstract classes are flexible, but in an interface, everything is public by default. And that makes sense, right? It's a public contract for the world to see.
Okay, let's bring this all home. We've gone through the what and the how. But why should you really care about mastering abstraction? What's the actual long-term payoff for you?
Well, the benefits are just massive. By hiding details, you make your code way easier to think about and understand. By creating these common blueprints and contracts, you end up reusing a ton more code instead of writing the same thing over and over. This makes your programs dramatically easier to maintain and update down the road. And hey, by only exposing what's absolutely necessary, you're also making your code more secure by protecting its internal state.
And get this number is absolutely wild. Some studies show that up to 70% of the total cost of a piece of software isn't in building it the first time, it's in maintaining it for years afterward. Every single time you use abstraction well, you are directly fighting against that cost. You're making life easier for your future self and for every other developer who ever has to look at your code.
This quote really just says it all. Because you separated the what from the how, you can now do amazing things. You can completely rip out a car's old gasoline engine and replace it with a brand new electric one. But as long as the steering wheel and the pedals, the public interface, stay the same, the driver doesn't have to relearn a thing. The whole system still works, and the rest of the world doesn't break. That, right there, is the power of abstraction.
So, I'll just leave you with this thought. We talked about cars, but what about the remote for your TV? The buttons on your microwave? All the apps on your phone? The entire modern world is built on layers and layers of abstraction. Once you start to see the pattern, I guarantee you'll start seeing it absolutely everywhere. Thanks for watching.